student. Welcome to YouTube channel Knowledge Lane, the physics classroom. Let us start revising the topic conical pendulum from class 12 HSC board. So on the screen, what you are seeing now is the diagram for conical pendulum. This is a rigid support. This is a rigid support by which a long, inextensible, flexible string, massless, or we can say a light string, is suspended. At the end of the string, the small point object or a tiny mass is attached. So this arrangement is known as a simple pendulum. Now, if this string of a simple pendulum is revolved in such a way that the string moves along a surface of a right circular cone with axis of a right circular cone to be vertical. What I said is, if the string of a simple pendulum is revolved in such a way that it moves along the surface of that right circular cone with the axis of a cone being vertical. Then in this case, if the tiny mass or the bob of a simple pendulum moves or traverses a uniform horizontal circular motion, or it traverses along a horizontal circle in uniform motion, then this entire arrangement is called as conical pendulum. So let us write the definition of conical pendulum. Definition: if the string of simple pendulum is revolved in such a way that it moves along the surface, of right circular cone with its axis being vertical. Axis being vertical. Then, if the tiny mass, attached at the free end of the string performs horizontal circular motion with uniform speed. Or you can say uniform horizontal circular motion. Then it is called as conical pendulum. Conical pendulum. Yes. Now, how the question is asked on this topic is, derive the expression for periodic time of conical pendulum. So this is mostly repeated in board exam. Usually the way you should write the answer for such kind of derivations or the derive the expression for type of questions, that first step you must draw a diagram which will clarifies or which with which we can write the explanation or the mathematical part. We need that diagram to explain the things. So let us draw that diagram. This is a rigid support from which a string is suspended. At the end of the string, a tiny mass is suspended. Now let us draw that circle along which this bob of a pendulum, or you can say a point mass, is performing uniform horizontal circular motion. Yes. So this is being the initial position before starting the circular motion. This represent radius of the horizontal circle. This is being length. This is vertical height. This thing is rigid support. And this is the angle theta made by that string with the vertical. So this is our, yeah, that's right. Now let us write the descriptive paragraph which describes this diagram. This is the second step, which is also much more important while getting good score for derive the expression for type questions. So let us write that. Consider a conical pendulum as shown in above figure. As shown in above figure. Consider the position B. So we'll write at position B. See, as the bob is traversing a horizontal circular motion, when it comes to the position B, what kind of forces are acting on that bob or a heavy sphere or tiny sphere of the pendulum? Let us show them and we'll write for the same. So at this position B, the weight of the pendulum acts vertically downward, which will write as mg. Now, as the bob is attached with the string, naturally the tension which is developed in the string acts towards the support. The tension T dash gets developed along the string and its direction is always towards a fixed support. So as the ball or the bob of the pendulum is performing uniform horizontal circular motion, let us find out which force is providing a necessary centripetal force to keep continuing the circular motion of the pendulum. For that purpose, let us resolve this tension T dash in two components. One, along the weight mg, but in opposite direction, and the second one perpendicular to that. So let us draw those components. See, this is the component of the tension which is balancing the weight mg, and along the mg, line mg, but in opposite direction. And the second thing, second is like this. This is balancing weight mg, and this thing perpendicular to this component but towards the center along the radius. So from the geometry of the figure, what we get is, as this angle is theta, this becomes theta, alternate angle. So this arrow represent the component which is T dash cos theta. So the force which is balancing the weight mg is T dash cos theta, the component of the tension along mg but in opposite direction. And naturally, this component is T dash sine theta, which is along the radius towards the center. Naturally, we know this component is providing the necessary centripetal force for a uniform horizontal circular motion of that bob of a conical pendulum. So let us write all these things. So when the conical pendulum or the bob of the pendulum is at position B, the different forces acting on the bob of a pendulum bob of conical pendulum are as below. The first will write the weight mg, weight mg, how it acts, acting vertically downward, acting vertically downward. And the second force which is acting on the bob is tension developed in the string. Developed in the string, which we represented by a symbol T dash, just to avoid the confusion between the symbol of periodic time and tension. And how this force is acting along the string towards the support, along the string towards the fixed support. Towards fixed support. So let us resolve. This is our third point, you can say. Let us resolve the force of tension T dash developed along the string, developed along the string in two components, such as first one, T dash cos theta balancing the weight mg, and Second one, t dash sine theta along the radius towards the center. Towards the center of horizontal circle. So from this information, what we know is we can write, this is our fourth point, we can write this information into equation form like thus t dash cos theta is mg since it is balancing along the same line of mg but in opposite direction. This is our equation 1, and t dash sine theta, which is providing centripetal force. Since it is along the radius, it is along the radius, let me write it neatly, along the radius towards the center. So we know the formula, the expression for centripetal force as mr omega square. So we can write this equation as t dash sine theta equal to mr omega square. Let us call this equation as equation 2. So if we divide equation 2 by equation 1, what we get? Dividing equation 2 by equation 1, we get, let us write that, t dash sine theta divided by t dash cos theta, which is the left sides of equation 1 and 2, is equal to mr omega square divided by mg. So here m will get cut. T dash is a tension developed along the string, which is the same. So it get cut. Now sine theta by cos theta, as we want the expression for periodic time, and periodic time is related to omega. So we'll rearrange this equation for omega square. Okay, so let us write that. Therefore, g sine theta by r cos theta is omega square. As t is 2 pi by omega, we know that. Therefore, here we write taking square root on both sides. Taking square root on both sides. We get omega is equal to, okay, here I have to open the new page. Omega is equal to under root g sine theta by r cos theta. So let us box this equation, since this will help us to find the angular speed of the conical pendulum, basically angular speed of the bob of a conical pendulum with which it is traversing or performing uniform circular motion. So let's write this also. This expression gives angular speed of a bob of a conical pendulum, or it is sometimes said like angular speed of conical pendulum also, with which it is performing uniform horizontal circular motion. Okay. Let us call this equation as equation 3. Now, we want to find out the expression for periodic time. So this is our fifth point. As we have got the expression for omega, now since periodic time is given by, as we know, periodic time is given by T is equal to 2 pi by omega. So if we use this equation 3 over here, we can write the expression for periodic time as T is equal to 2 pi under root G sine theta by R cos theta. So if we rearrange this, it can be simply written as 2 pi times under root R cos theta by G sine theta. Now, instead of going back to previous page, here I just draw a rough figure of the conical pendulum with which we can just take the help to see how this formula can be get transferred to another form. So this is a conical pendulum. This is the position B and the circle along which this is a position B and different forces. This is R, radius of the circle. This is H and this is L. This is being theta. So what we want, this is R can be replaced. See, if you observe the figure, R is opposite side to this angle theta. Now the trigonometric ratio which is related to the opposite side is sine, and this is a hypotenuse. Since this is a right angle triangle, so we can write here from geometry of this figure, we have sine theta is equal to opposite side upon hypotenuse, which is L. And from here, we can get the expression for R as L sine theta. So box this expression also, and let us box this expression also like this. Let me write neatly. T is equal to, and this equation, let us call this as equation 4. So if we use this R as L sine theta, in this equation 4. What we get is this. Thus, using r equal to L sine theta in equation 4, we get, or you can say, substituting r equal to L sine theta in equation 4, we get t is equal to 2 pi as it is under root. In place of r, now we are writing L sine theta. That cos theta will appear as it is divided by g sine theta. So here we see sine theta is same, so it will get cut, and we are now getting our final expression for periodic time of a conical pendulum as t is equal to 2 pi under root L cos theta by g. Yes, this is the required expression for periodic time of a conical pendulum. Yes. Let us write that in a statement form. This expression gives periodic time of a conical pendulum. Now, moving ahead of this, we know periodic time is related to frequency also. Periodic time is what? It is the time taken by that object. Now here object is a conical pendulum to complete one revolution. And frequency is what? Is the number of revolution completed or performed in 1 second. So using this expression, we can write the formula for frequency. I'm not saying angular frequency. We are writing the expression for frequency. How many revolutions get completed in 1 second. So this T equation for T will help us. So frequency of conical pendulum is given by, the simplest form is n is equal to 1 by t. N is equal to 1 by t. So this is one of the formula, very basic formula, all of you know. But using this expression, what we can write, n is equal to 1 upon, if we substitute the expression of t over here, it will look like 1 upon 2 pi under root L cos theta by g. So when you rearrange this equation, it will look like n is equal to 1 upon 2 pi multiplied by under root g by L cos theta. So box this equation as it is an important one. So for frequency of conical pendulum, you have two expressions. One is this direct value. If t is given, we can simply use 1 by t. If not, L, theta and g is given, we can use this expression. Now, in the expression for periodic time, what we have, I think this is our sixth point. What we have, t is equal to 2 pi under root L cos theta by g. This is the equation for periodic time of conical pendulum. Now, if you observe the figure, if I just draw a rough diagram for that to have a good recall of the concept. Sorry. without drawing any details. What we have, this is angle theta, this is a vertical height, this is a slant height, or you can say a length of a pendulum, and this is radius of the circular track along which the bob is performing horizontal circular motion like this. Okay, so this H, which is the adjacent side, this one, to the angle theta. So this H is nothing but L cos theta. Why? Since cos theta is written as adjacent side upon hypotenuse, so H will be L cos theta. If you use this in the expression for periodic time, here, over here, for this term, then we have the equation for T, or a formula of T in terms of vertical height also. Simply replace this L cos theta by H. So T is equal to 2 pi under root H by G. Yes. So these are the different formulae for periodic time of a conical pendulum, which can be used to solve different either objectives or numericals. Thank you. So if you like this video, if you like this way of my teaching, do follow my YouTube channel, Knowledge Lane, the Physics Classroom. Here you will find different concept to be getting explained in a very simple language, with just you have a feel of live classes going on. If you like it, just like, share, and subscribe my channel. Share this with your friends, and see you soon in the next video on a next topic. Thank you.